Today, I'm going to bring you into the exciting world of the honeybee, the only insect that produces food for human consumption. How exactly do these bees make honey? Different honeybees have different jobs. Some of the bees are forager bees, which collect nectar from flowering plants. The foragers drink the nectar and store it in their crop, or honey stomach. The forager bee then takes the nectar back to the hive and regurgitates the nectar directly into the crop of another bee at the entrance to the hive. The processor bee takes the nectar to the honeycomb and regurgitates it into a wax cell.
In this step, we meet the first key enzyme in the reaction, invertase. Nectar is mainly made up of sucrose. The enzyme invertase splits up sucrose into two 6-carbon sugars. These are commonly referred to as glucose and fructose. Of these two sugars, glucose is the one that undergoes further enzymatic processing. A small amount of the glucose is attacked by a second enzyme, glucose oxidase. Glucose oxidase catalyzes the oxidation of glucose into gluconolactone. Gluconolactone further spontaneously hydrolyzes to produce gluconic acid, the principal acid in honey. In addition to gluconolactone, glucose oxidase simultaneously forms hydrogen peroxide during its action on glucose. The H2O2 is then cleaved by catalase to produce water and oxygen. I know we just went over a lot of information, so let's just review really quick. Invertase converts the main sugar in nectar into glucose and fructose. Glucose oxidase then converts some of that glucose into gluconolactone. Gluconolactone spontaneously turns into gluconic acid and hydrogen peroxide. Hydrogen peroxide is then converted into water via the enzyme catalase. We talked a lot about the chemistry behind the whole process now, but why is this significant to us? Why should us Georgia Tech Yellow Jackets care about the humble bumblebee? Aside from honey being a delicious sweetener, we can look far beyond the food industry. Knowing the chemistry behind the honey-making process has important implications for commercial use and industrial uses. Remember the enzyme glucose oxidase we just went over? Glucose oxidase may seem just like an ordinary enzyme, but over the past few years it has become more commercially important. It's gained a multitude of different uses in the chemical, pharmaceutical, food, beverage, and other industries. Glucose oxidase isn't the only important enzyme either. Additionally, gluconic acid, which is produced from the hydrolysis of gluconolactone, has its own important industrial uses. It can be used as packaging to prevent growth of bacteria, as well as controlled bacterial growth in lab settings. Another major area of interest is using glucose oxidase as a biosensor for monitoring diabetes. While honey has a long history in human consumption, it's clear that its full potential has not been tapped. We can continue to learn more about the biochemistry of these enzymes and use them to our advantage. Honey isn't just a sweet treat, but something much more amazing.